In this video, we are going to be solving a percent composition problem for the following problem. So my question states, determine the percent composition of each element in 1 mole of ammonium phosphide. So the first thing we want to do is find that compound formula for ammonium phosphide. So ammonium is NH4 with a charge of 1 plus, and then phosphide is phosphorus, which is P, with a charge of 3 minus. And since our charges do not equal up to 0, that means we're going to have to go ahead and cross our numbers in order to get our compound formula, which is going to equal NH4 in parentheses 3P. So we know that the elements that we are solving a percent composition for is going to be N, H, and P. So now we want to go and solve the molar mass of each element in the compound. So we have N, H, and P. And we know according to our compound formula, N has 3 moles because the 3 is outside of the parentheses and is going to be distributed to each element within the parentheses. So N has 3 moles. H is going to have 12 moles because 3 times 4 is 12. And then phosphorus has 1 mole because there's only 1 of it. Now we are going to multiply N by its molar mass, which is found on the periodic table, and that is going to be 14.01. So once we plug that into our calculator, so 14.01 times 3, we get 42.03. 42.03 grams per mole. Now for hydrogen, the molar mass on the periodic table is going to be 1.01. And once we plug that into our calculator, so 1.01 times 12, we get 12.12. But since we only have 3 significant figures in 1.01, that means our final answer has to have 3 significant figures, so our answer should be 12.1 grams per mole. And then for phosphorus, that molar mass from the periodic table is going to be 30.97, and 1 times 30.97 is going to be 30.97 grams per mole. Now we want to find the mass of our compound. So like we said, that is NH4, 3P. And what we want to do is add up all 3 of our elements' molar masses. So 42.03 plus 12.1 plus 30.97 gives us 85.1. And according to the significant figures rule for adding and subtracting numbers, we want to look at the least number after the decimal place. So we see that 42.03 has 2 numbers after the decimal place, 12.1 has 1 number after the decimal place, and 30.97 has 2 numbers after the decimal place. Therefore, our final answer should only have 1 number after the decimal place, so 85.1 is going to be our answer for the mass of our compound. So now, in order to find the percent composition of each element in our 1 mole of ammonium phosphide, we want to go ahead and use this formula down here. So percent composition equals mass of element divided by the mass of the compound times 100. So for N, we're going to go ahead and plug in those numbers. So our mass of our element is going to be 42.03. Our mass of our compound is going to be this 85.1. And then we're going to multiply that by 100. So once we plug that into our calculator, so 42.03 divided by 85.1 times 100, we get 49.388. Well, Our 42.03 has 4 significant figures, and our 85.1 only has 3 significant figures, which means our final answer should only have 3 significant figures. So therefore, our answer is going to be 49.4 because that 8 is going to round up that 3. So 49.4%, and that's going to be our unit, our percent sign. So now for H, we're going to take the mass of the element, which is 12.1, divide that by the mass of the compound, which is 85.1, and multiply that by 100. That is going to give us an answer of 12.1 divided by 85.1 times 100. That's going to give us an answer of 14.218. But 12.1 has 3 significant figures and 85.1 has 3 significant figures, so therefore our final answer should only have 3 significant figures, so our final answer is 14.2%. And then for phosphorus, again, we're going to take the mass of that element, which is 30.97, divide that by the mass of the compound, which is 85.1, multiply that by 100, and when we plug that into our calculator, we get 30.97 divided by 85.1 times 100. That's going to give us 36.39. But again, 30.97 has 4 significant figures and 85.1 has 3 significant figures. Therefore, our final answer should have 3 significant figures. So our answer is going to be 36.4 because that 9 is going to round up that 3. So 36.4%. So now we have solved the percent composition of each element, but before we go ahead and write out our final answers, let's just go and make sure that our percents equal up to 0. So, or not 0, 100%. So 49.4% plus 14.2% plus 36.4%, that is going to equal 49.4 plus 14.2 plus 36.4. That is going to give us an answer of 100.0% because again there is one number after the after the decimal place, so therefore we should have a number after the decimal place because it is significant. So all our percents equal up to 100. So now let's go ahead and write out our final answers. So for the percent composition of nitrogen in our compound, that's going to be 49.4%. Our percent composition of hydrogen is going to be 14.2%, and then our percent composition of phosphorus is going to be 36.4%. If you have any questions about anything I did in this video, please feel free to contact me so I can further clarify anything for you.